programs at Amrita School of Engineering, Bangalore, will be addressed by Dr. T.K. Ramesh, Associate Professor and Vice Chair, Department of Electronics and Communication Engineering, Bangalore. The role of communication and information for Industry 4.0 will be handled by Mr. K.S. Srikanth, System Architect from Intel, and Mr. S. Sivasubramanian, Component Design Engineer from Intel, followed by an alumni talk. We would be handling all the question and answers towards the end of the session. As we progress towards the webinar, I request you all to kindly mute yourself, and if you have any questions, kindly key in the chat box. We will handle the questions towards the end of the session. A hearty welcome to the audience for joining this informative webinar. Over to Dr. T.K. Ramesh, Vice Chair, Department of ECE, Bengaluru. I request the audience to stay tuned. The webinar is about to begin shortly.
We are waiting for Dr. Ramesh to.
Hello?
Yeah, I'm able to hear you.
Yeah,
Ramesh.
I cannot see the PPTs. Yeah. Okay. Good morning to one and all. On behalf of Department of Electronics and Communication Engineering, I'm very happy to welcome all of you to this webinar on role of communication and information for Industry 4.0. Today, we have with us two eminent personalities from the industry who are also my PhD scholars to speak on the topic role of communication and information for Industry 4.0. I am very honored to introduce them. We have Mr. K. Srikanth. He is a system architect in Intel Technologies, Bengaluru, with an industrial experience of 20 plus years. He was the recipient of Dr. Raja Ramanna Gold Medal and V. Prakash Endowment Gold Medal during the 1999 annual convocation at Mysore. To his credit, he has two US patents, one related to autonomous navigation and the other related to HART communication protocol. In today's webinar, Mr. Srikanth will be discussing about the significance of information systems for Industry 4.0. Welcome, Mr. K. We also have with us Mr. Hello, I'm audible?
Yes, sir, you're audible.
Some noise is coming there. Okay. We also have with us Mr. S. Sivasubramanian. He has more than 28 plus years of experience in the field of aerospace, quality, reliability, safety analysis, and development of spacecraft subsystems. Shiva has served in Space Applications Center, ISRO, Ahmedabad, Aeronautical Development Agency, DRDO, Bengaluru, and Animal Technology Solutions Lab, Bengaluru. He is currently serving in Intel Technologies, Bengaluru as a functional safety manager. He has two patents and few publications in reputed journals and conferences. In this webinar, Mr. Shiva will be discussing about the importance of communication in industrial scenario. Welcome, Mr. Shiva. Amrita Vishwa Vidyapeetham is a multi-campus, multidisciplinary, private deemed to be university. Currently, it has 6 campuses with 15 constituent schools across Tamil Nadu, Kerala, and Karnataka. The university was founded with the opening of Amrita School of Engineering, Coimbatore in 1994 by Mata Amritanandamayi Devi. In 2003, it became one of the youngest institute to be deemed a university status by the UGC. Sadhguru Mata Amritanandamayi Devi is the chancellor of our university. She is a renowned humanitarian leader and spiritual teacher. Amma is the guiding light of Amrita Vishwa Vidyapeetham. University offers a total of 207 undergraduate, postgraduate, integrated degree, dual degree, doctoral, and certification programs in engineering, medicine, business, arts and science, agriculture, biotechnology, mass communication, and social work. The university has 20,000 plus students, in which 900 plus are PhD scholars. University has a faculty strength of 2,000 plus, with 800 plus faculty having doctorates and 180 plus being international faculty. 12,000 plus publications in reputed journals and conferences with a citation of more than 40,000. At present, Amrita has 6 campuses at Amritapuri, Bengaluru, Chennai, Coimbatore, Kochi, and Mysore. 2 more campuses are coming up in Amravati and New Delhi. Our ranking are as follows. Times Higher Education World University Ranking 2020 ranked Amrita as #1 private university in India. Amrita has been ranked as the 8th best university in India by National Institutional Ranking Framework (NIRF) under MHRD Government of India. In September 2019, the University Grant Commission, UGC, has recommended institutions of eminence, IOE status to Amrita Vishwa Vidyapeetham, which will provide Amrita almost complete autonomy in its functioning and freedom from the regularity mechanisms. Why do you have to take MTech at Amrita? We ensure scholarship for all eligible students. We have about 30 specializations across 3 campuses, dual degree programs, which means an MTech from Amrita University and MS from foreign universities, like in USA, Europe, or Australia. Some of our patent universities are listed. We offer integrated MTech and PhD in a span of 5 years. We also provide internship opportunity not only in India but also abroad. We have a separate center called Amrita Center of International Programs, ACIP, to take care of it. Amrita provides placements for all the eligible students. Our placements and internships are as follows. And we have Amrita Technology Business Incubator Center, which helps students for early stage startups and innovators for commercializing their innovative business ideas by providing funding, services, and infrastructures. We have 30 MTech specializations at Amrita, 12 at Amritapuri campus, 7 at Bengaluru campus, and 16 at Coimbatore campus. Amrita School of Engineering at Bengaluru was established in the year 2002 and was affiliated to Visvesvaraya Technological University. It was brought under the ambit of Amrita Vishwa Vidyapeetham in the year 2004. Campus has a very good library and hostel facilities. BTech, MTech, and PhD programs in engineering and sciences are offered at Bengaluru campus. Department of Electronics and Communication Engineering at Bengaluru campus offers BTech in Electronics and Communication Engineering, Electronics and Computer Engineering, MTech in VLSI Design and Communication and Information Systems, and PhD in Engineering. Department has a team of dedicated and experienced faculty in the areas of electronics and communication engineering, and also has research labs like advanced communication, radio frequency engineering, nanoelectronics, networking, and VLSI. Our department also has 6 thrust area groups for doing research in the area of advanced communication, communication networks, nanoelectronics, RF and wireless systems, signal processing, and VLSI systems, architecture, and circuits. We have a corporate and industry relations department to provide expert guidance to students in specific areas beyond their regular academic curriculum and help them to fulfill their career ambitions. These are the list of some of the companies where our students have taken internships and were placed. Today, we have 2 of our MTech CESP students who did their internship and got placed in Tejas Networks and FireEye to share their experience. At present, Department of ECE at Bengaluru campus is having master's program in VLSI and CESP, that is Communication Engineering and Signal Processing. But we know that the next phase of industrial revolution in is Industry 4.0 and is currently underway. Industry 4.0 revolution is for creating smart industry for the future. So knowledge in the areas of communication as well as information science is essential to be ready for Industry 4.0. Also considering the inputs of experts from industry and academia, Amrita is proactively bringing out a master's program, MTech in Communication and Information Systems, to prepare a future talent to meet this need. This program focuses on information processing and communication systems using mathematical methods and computer technology. Students will be trained in advanced software tools, variety of information processing, modern digital communication, broadband network technologies, etc. to take up the aggressive needs. Students will get to attend classes by industrial experts. MTech in Communication and Information Systems is also intended to serve working professionals to acquire these skills while continuing their regular work. In today's webinar, you get to listen from industry leaders their perspective on communication and information systems. They will also let you know how this program would benefit and create tomorrow's leader in this area. Now I would like to call Mr. K. Srikanth to take over.
Hello, Mr. Srikanth. We are not able to hear you. I think you need to unmute it.
Okay, can you hear me now?
Yes,
Yes,
Srikanth,
you are
now it's
audible.
audible. Now it's
Okay,
Yes,
audible.
sir, we are
sure.
able to hear.
We missed the last three slides, so can you
Sure,
repeat it? It will be good.
sure, I will. So let's
Yes.
let's go to Industry 1.0. Let's try to understand the differences between Industry 1.0, 2.0, and 3.0 quite briefly. Initially, the human being was in search of food and he wanted to get his food in a fast rate. So he invented the wheel way back in 3000 BC, 3500 BC. That was the initial kick for the industrial revolution. Once that happened, it started with lot of mechanized work where we had hundreds and thousands of people who were actually working together in order to get their products delivered. This led to a lot of slavery and lot of discrimination between people. In Industry 2.0, the main focus was on mass production and use of assembly lines. Electrical technology or electrical engineering became a major contributor here. Industry 3.0 was mainly related to automation and the evolution of computer application. Now, we identify that different people are located in different places in the world and each of them have a different specialty. How about connecting all these people virtually so that we can achieve a common goal of producing a single reliable product? This led to the origin of Industry 4.0. Industry 4.0 mainly dealt with cyber physical systems, Internet of Things, and networks. These are the main focus areas for Industry 4.0. If we look at these two pictures, what we have smart revolution where the initial Stone Age people used stones to actually grind rice and make their rotis or make their dosas every day. This has changed or evolved. This has evolved to request all participants to kindly mute themselves. This has evolved to use of smartphones and smart technology to make our life more convenient. This has actually enhanced our way of life. Now, let us see how long it has taken for us to reach 100 million customers. Initially, the telephones took around 75 years to reach 100 million customers. The World Wide Web took 7 years, Facebook 4 years, Instagram took 2 years, and look, Pokemon Go has just taken 1 month to reach 100 million customers. Nowadays, a TikTok video or a YouTube video reaches 1 million views in less than a day. Now, let's see how things evolved from years to days. Just look at these interesting statistics that we have right from March 25th to April 10th. The most downloaded applications. We have got Zoom, which has got more than 14 million downloads. TikTok has got around 14.1 million downloads. Arogya Setu app has got 13.4 million downloads. As you can see that all these applications are reducing from days or years to days, and now it's even reducing to hours. For example, a YouTube video posted today gets 1 million views and almost 5,000 likes within the next 4 hours. It just indicates how connected the entire world is. Now, let us look at what are the trends and opportunities that we have for enabling Industry 4.0. First thing is we have got a very high processor compute, which is quite cheap and available. We have got, for example, high-end microcontrollers and SoCs, which are available to us at very low price. We have got a willingness to buy from the people. We have got a connected world where people are located at different points and they are able to connect to each other in almost zero time. Just imagine if you had to call your friend who is staying in the United States of America 20 years ago, we had to book a trunk call and it used to take 45 minutes, 1 hour. You never know how long it will take for the person in America to get connected with you. But now the same thing is happening just by a press of a button. You just start a WhatsApp call and immediately you are connected with your friend who is in America. Lower cost, connected world, and higher compute power are the trends. What is really required for the industry now? We need industry ready engineers. We need engineers who have knowledge of latest technologies, and we need engineers who are willing to innovate. Our MTech program at Amrita for C&IS will act as an enabler. We will look at what are the different job openings and what are the tools and techniques that a person needs to learn in this course and what the student will be exposed, what opportunities they will get as we go through in the session. Now, let us understand what is Industry 4.0 and let us try to get the definition of Industry 4.0. Industry 4.0 mainly speaks about a collective term of technology and concept of the value chain organization. The name itself sounds very confusing and very complicated. Let us break this statement into simple, understandable terms. What is Industry 4.0? Industry 4.0 is a technology concept of cyber physical systems, Internet of Things, and Internet of Services. Now, let us understand these three terms in a little bit detail. What is a cyber physical system? Any connected system to the internet is called as a cyber physical system. Okay, that's quite easy. What do we mean by Internet of Things? This is a highly misused word and misunderstood word. Let us try to understand this. Let us say the main role of a human being is to improve his way of life. So, what will a person need the moment he gets up in the morning? The moment he gets up in the morning, he would prefer to have a hot cup of coffee, a hot water to take bath, and an approach to actually help him prepare his breakfast and prepare the menu he wants. What if all these are connected and the workflow is automated? For example, when the alarm clock rings and the person wakes up, automatically the geyser is turned on, the coffee kettle is turned on, and by the time he is fresh, by washing his face and gets to the kitchen, he gets a hot cup of coffee, which is quite easy to make. And what if the device already activates the toaster and toasts him 2 slices of hot bread? How wonderful it would be for the person. This is all possible with Internet of Things. Now, what do we mean by Internet of Services? Internet of Services means providing a service over the internet. Let's try to understand with an example. In case your tap is broken in your house, what would you do? You would call a plumber who will physically come to your house and repair the system. What if we replace this process of repair as a service which can happen over the internet? Firmware on the air upload FOTA is one such service where if there is a bug identified in the firmware or the software of a computer, it can be updated online using the Internet of Services. The service provider will know the affected system and update the firmware without the user really knowing of it, which is a very good thing. This helps in improving the availability of the system. Further, it can be used for predictive maintenance. Let us look at an interesting scenario of ordering customized meals to patients. This sounds quite amazing. In a hotel, they serve food for hospital patients who are in various wards. Now, if the hospital has a tie-up with a hotel where the database of patients who are admitted are shared in real time to the given hotel, they can customize the food based on whether the patient is diabetic, whether the patient needs high protein food, or whether the patient needs low salt food. These things can be customized based on the connected device that we have. Now, let's look at the major difference between a traditional industry and Industry 4.0. A traditional industry had manual labor. Industry 4.0 has smart labor. Use of machines. Here we have use of man, machines, and robots. They coexist. Consolidation of work at one place. Here it is distributed across multiple sites. Isolated system versus connected system. This is where we are heading to. Now, let us look at a very important field. Let us look at a very important.
It's okay.
Kindly mute yourself if you are not speaking. Okay, let us look at the different fields that are very important which makes us march towards Industry 4.0. First of all, let us understand the superset. The superset, what we have is artificial intelligence. What is artificial intelligence? Artificial intelligence is mainly applying the intelligence of a human being using a computer, where the computer is able to mimic the responses of what a normal human being would do. This is a universal set. Now, let us look at the subset of artificial intelligence, which is deep learning, and its subset machine learning, and we will start with the initial thing called data science. Now, how does a computer take decisions? A computer takes decisions only based on data. So the first and foremost important point that we need to look at is data science. Data science deals with the science of gathering data, cleaning data, subsetting or logically grouping data, data manipulation, and data visualization. This is the first field of data science. This particular field requires a lot of knowledge on mathematics and statistics. Now, data science leads us to a new concept where we are able to model whatever we have learned from the data into a machine learning algorithm. So, conversion of the data that we have got into a mathematical equation is called as machine learning. There are three types of machine learning, as we know: unsupervised machine learning, supervised learning, and reinforcement learning. So data science acts as a feeder to machine learning, and machine learning, if it is learnt by the computer by its own, or the computer learns on its own about the data, then we call that field as deep learning. Neural networks, recurrent neural networks, and convolutional neural networks are classical examples of deep learning. Object detection, image processing, speech processing, natural language processing all come under deep learning. Under machine learning, we have got regression, logistic regression, classification, clustering. All these come under the machine learning gambit. Now, we understand that in communication and information system, it's all about information. And where does information start with? It starts with data. So what does a person need to know if they need to get into an Industry 4.0 ready engineer? They need to start with data, apply this data using machine learning, enhance their knowledge using deep learning, and focus on communication. So there are two topics that are very critical: information systems and communication systems. We are right now dealing about information systems. Let us now look at cyber physical system, which is another important aspect of Industry 4.0. We have got 5 different systems which are connected together, or 5 different levels in which the systems are connected. We have a smart device known as the edge device, which is a level 1 system. Now, let us understand what is a level 1 system or an edge device. We saw the picture of a smart kettle which is able to give us hot water or brew us coffee by click of a mouse or by click of a button from a mobile phone or a smartphone. This device, which actually sits on the edge and does the final control element actuation, is called as an edge device. Edge devices are smart devices that are able to take smart decisions. However, their footprint is small, their memory capabilities is small, and they are embedded systems which consume the least power and has as much as functionality required to control the edge device. The next level, after the edge device processes the data, it needs to send the data for smart analytics. This is where the data science layer comes into picture. Once the data has been gathered from different systems, it needs to be communicated to other devices. This is where cyber level comes into picture, where the devices are connected over the internet and they communicate with each other. So, cyber level deals with communication and cyber security aspects of the data. The fourth level deals with the cognition level, or the level where we are able to represent this data as a mathematical model, and the mathematical model is taking decisions on behalf of the human being. This is the fourth level where we have cognition level. The fifth level is the most important level where we have deep learning. The machine starts learning based on the data that we have got and takes decisions on its own without human intervention. Why this is very critical? Just imagine a spacecraft which is actually going from to the International Space Station. We cannot expect a human being to take a decision because he is under a lot of pressure. His state of mind is not stable for him to take a decision. We need to let the computer override the human being and take a decision. Look at instrument landing system present in an aircraft. An instrument landing system takes control of the entire aircraft and lands the aircraft safely based on the data that is available with it and the learning that it has got from the past. So, the three major pillars of Industry 4.0 would be embedded systems, cyber physical systems, and Internet of Things. What would be the enabler for all this? Data science, machine learning, and artificial learning. Now, let us switch from information systems to communication system and try to understand how the technology evolved from 1G communication to 5G communication. You might all have seen a mobile phone which is present in a museum. It used to weigh as heavy as a brick. The 1G technology provided cellular connection which was very heavy, very unreliable, and I remember some of my teachers calling me and telling, "Hey Srikanth, I am Dr. Mohan calling you from my mobile phone." You know, as a person who is receiving the phone on a landline, I will really not know whether the person on the other end is speaking using a mobile phone or a landline phone. It was a sense of prestige to say that I have a mobile phone, which most of the people do not have. But these days, mobile phone is becoming a joke, and a child which is born in the hospital first takes a selfie of itself before it starts crying. This is what is happening with technology and the evolution of technology. 1G technology had cellular phones which were very bulky and heavy. 2G technology introduces smart texting and email services. 3G introduces web technology and smartphones. 4G technology helped in high definition data streaming and real time data streaming. Now, with 5G communication, which is the foundation for Industry 4.0, we have real time data communication across connected device in order to take real-time safety critical decisions and keep the system operational over time. This is how the cellular technology is enabling us to march towards Industry 4.0. Let us look at the different features that we have got in the cellular technology from 1G to 5G. 1G started with advanced mobile system, or it used the basic cellular phone technology. 2G had total access communication system and code division multiple access. CDMA was one of the interesting technologies that were introduced in 2G, which helped in smart texting and sending emails. 3G technology improved the bandwidth with which the data was sent, thereby sending a large amount of data in lower time. 4G and 5G definitely are improving the bandwidth, and newer technologies like orthogonal frequency division multiplexing and beam division multiplexing are being used. Now, as we can see, these names itself sound a little scary. They are really not scary because the course that is being held at Amrita will ensure that the latest technology is introduced to the students, and they are not going to be surprised when they hear these terms when they go out in the market. It will not only help them to learn the concept quite well, it will also help them to answer questions in their interviews quite confidently. With this, I would like to welcome Shiva to take us through the communication with respect to Industry 4.0. Over to Shiva.
Yeah, thank you, Srikanth. Hope I am audible to everyone. Can somebody confirm?
Yes, sir, you are.
Thank you. So let us look at Industry 4.0 from the context of the communication systems. So far, what Srikanth explained is about the information system. Now we are basically trying to communicate or interchange or exchange the data between systems. So how do we leverage the available communication systems for that? So before that, let us understand what are the core characteristics of Industry 4.0. This is referred as a vertical characteristics. When you say vertical characteristics, is something within an organization, and how this organization, like you can imagine, it is like multiple pillars for Industry 4.0. The first element is vertical networking. So what does that mean? Is all the physical processes that we are having today in a conventional industry are going to get digitized. They are all going to be digital processes. What does that mean? Every input, every process parameter, every output a process is producing, they're all going to be monitored. They are all going to be controlled by it in the digital domain. So that is basically the digital to physical process conversion. Shifting of demands, stock levels, equipment fault. If you look at any industry today, the industrial production is going to be heavily dependent on what is the demand I have, how much of stock I'm keeping, whether all the equipments in a particular industrial given scenario, they're all in a working condition or not. Now with Industry 4.0, the industry is going to become very, very intelligent in deciding how the demand is going to fluctuate, what is the stock levels I have and what is needed, and which are all the equipments that are currently operational and what is going to fail in future. So it is going to be highly intelligent, predictive, and hence the uncertainties of future are going to be reduced. When you reduce the uncertainty of the future, the production quality is going to improve. Stress levels of people are going to be very, very less. So it is going to be a predictable production, and that is why it is referred as the industry of future or factory of future. The next pillar of an Industry 4.0 is the horizontal integration via global chain networking. We know what is the global networking and what is the horizontal integration here. It is like the integration of physical systems to the digital, but the execution has to happen in the physical world. So again, you have to turn back from digital to the physical. So it is a kind of a loop you can imagine, physical to digital, digital to physical, and so on. So it's going to be a kind of a wheel that is going to be rotating. And the networking of things within an organization and quick response, that is something like when there is a change or when there is a deviation, the response to that deviation is going to be in a very fraction of a second, because the decision processes are going to be digitized. So everything is going to be available, monitored, and hence it is going to be very fast. Logging every process. So so far in a conventional industry, people identify what are the parameters that you need to monitor, and they make provisions called as maybe testability provisions or test or maintainability provisions, by which I will be able to monitor such heartbeat parameters. But with the system in industry 4.0, every element of a process is going to be recorded, is going to be monitored. So control becomes very easy, very fast, and very quick. Very fast, and is going to be highly quality control. The next level is going to be through engineering. What it means is, we know about a product development. A product development requires multiple groups to come together and then try to create a product value, right? About the design teams have to come, component procurement has to come, and then integration and assembly has to come, testing has to happen. And then you say, okay, this product is ready for customer use. So now all these elements of a product development are going to be simultaneously linked, and hence they are all going to be talking together when the product gets. Hello.
Please
Hello?
go ahead, sir. Please go ahead, sir.
Yeah, okay.
Now we are not in the middle. It went. Now it is
Sure.
okay.
Sure.
Okay.
Please go ahead, sir.
Hello, sir.
Okay.
Yeah, please go ahead, sir. Please continue,
Okay.
sir.
Sure. Okay. Okay. So the integrated product development, as we have seen. So what is that we are going to achieve with the integrated product development? A synergy between the product development and production systems. What does that mean? What is needed for production will be available and required products will be developed. So it is going to go hand in hand. There is no waiting time and then no lag, and it is going to be on time, just in time kind of a production. Then last one, but not the least, is the acceleration through exponential technology. If you look at, technology is moving faster, machine learning, deep learning, etc. What are their basic purposes is the machine is going to be much more intelligent, connected, and then it is going to be making its own decisions for the future. So every industry in 4.0 are going to adopt all these technologies. And augmented reality. So augmented reality is not reality, it is augmented reality, by which you have digital cues, digital sounds, and digital information superimposed on the reality background, right? So it is little different from the virtual reality. Virtual reality is closer to the virtual world, and you completely immerse into the virtuality, and forgetting about the physical world, what is around us. Whereas in augmented reality, you will be in reality, you will be in with the real world with additional digital support, by which your knowledge about the real world is going to be much more superior than what it is today. For example, we can say about the situational awareness of a fighter pilot when he's flying in a war zone. So he'll be knowing about what is going on around, and and also there will be a digital advisory. Okay. So digital twin is nothing but a virtual world that is going to work along with the real world, and then enabling the real world to make decisions. That is what is the digital twin. So it is basically a digital model which is going to be running in parallel. And of course, we all know about robotics and industrial IoT. So IIoT. So industry 4.0 is going to be completely amalgamation of adopting the new technologies and working with these 4 pillars, vertical pillars. Okay, so what are the key technologies? As we have just now seen, the way that things are going to be identified, tracked, and transported is going to be completely different. It is going to be using big data analytics, next generation sensors, smart sensors, communicating sensors. They are going to be connected, and industrial internet of all the things. Everything is going to be connected with the internet, and then RFID and real-time locations tracking, right? And then automatic guided vehicles. So no manual intervention is not at all needed, and it is all going to be centralized, controlled, and monitored, and data is going to be logged so that we know about how to improve the efficiency in real time. Human interface, the way how human beings are interacting with the machines are going to be completely different. Machines are going to be intelligent, and hence they are going to talk to human beings what he needs, what help machine needs. So it makes life of a human being much more simpler. He has to be just watching how the machine, whether the machine is doing its right job or not. What is the benefit of this? That it doesn't mean that machine is going to be taking away the work of a human being. In fact, human beings' times are going to be precious, going to be spent on better jobs than just doing the regular routine works, right? That is how you can exploit the core intelligence of a human being. So augmented reality, we have seen computerized maintenance management is going to be completely predictive management, is not going to be reactive or a reactive management where you start attending to a problem once a failure happens. Is going to be completely predicting when the failure is going to happen. Are you ready to tackle that failure? So something like when COVID is going to happen, we are going to predict how this number of cases getting that are affected, how that is going to move forward. So that is how the decisions are based on. So maintenance is going to be in that way. And manufacturing is basically additive manufacturing. We know additive manufacturing is different from the conventional manufacturing of removing the material, and that is going to be much more efficient. And the good example is heart walls and things like that. They are now in additive manufacturing mode methodology that is being developed. Collaborative energy harvesting, of course, collaborative robots. So multiple robots working together to add value, to do a common job without really affecting the safety of the environment. Artificial intelligence, machine learning was talked about in the information part. So that is the core of building all these intelligence into the machines. Security, safety, and services. When we look at cyber security is most important. You need to have access only to those people on need to have access basis. Quality of service. So when we have an internet of so much of internet services, which is kind of giving so much of flexibility to people, and it is going to do jobs are in autonomous mode, machines have to do their job safely. So I'm going to hand over the entire decision process to a machine. What if machine malfunctions or misbehaves? So that is what is the quality of service and linked with the functional safety. So we are working on that area as well in Amrita University. Collaborative platforms. So platforms are not going to be isolated. They are all going to be exchanging the information and intelligence. So the platform which is in the downstream is going to be aware of what the upstream platform has done, whether he has to tune himself for the for receiving the next level or taking forward the product. So product lifecycle management, as we know, it is going to be completely computerized. And that is basically to decide how do I handle the deviations, how do I handle the variations in the product. So that is going to be, the intelligence is going to come from the computer itself, right? So now with these technologies, the entire industry 4.0 is going to be enabled. And now if you look at here, everything is based on the data and information processing and communicating that information to the next level, so that in a proactive way, the systems can be tuned. Now, how this communication is going to be received by the world, if you look at the amount of investment European industries are going to do is about 140 billion in the industry, out of which 3.9%, roughly about 4% of investment is going to be on communication. And we can imagine the emphasis on communication. And that investment volume per annum is going to be about $16 billion euros. So that is the amount of cash that is going to be injected into the system for the development. Okay, now let us look at a industry footprint. You can see the lower level edge devices involves various elements like it can be a robotic arm, and it can be a machine, it can be a tractor or a vehicle or a truck. So all these elements are now going to be communicating. And what is the benefit of their communication? We have seen before. We are going to be much more knowledgeable and driving the decisions. And these edge devices are going to be communicating with the computers or the routers through various communication networks. It can be an RS-485 communication, or a high-speed Ethernet communication, or a fundamental edge sensors are going to be communicating using their own dedicated links or buses. And with all these all these communication networks, the information is going to be shared across the industry, so that every information is going to be processed at various levels, and then the decisions are going to be driven. If you look at the diagram on the right hand side, it gives an idea about what are the various edge devices. You have a scanner, you have a transport vehicle, and so on, and you have multiple protocols that are going to be carrying that data for next level of processing. So these protocols are going to be built with enough intelligence and robustness so that there is nothing goes wrong. Even if there is an issue of error or change of the corruption of the data, that can be very easily handled, and the information that a gateway is going to receive is going to be fault free. So that is the basic fundamental way how the protocols are getting defined. And once the gateway receives it, you don't have to take it to the entire internet or to a longer a server which is kept very deep. It can get processed at the cloud, so that the processing time is going to be smaller for quick decision making. So once the process happens in the cloud, the informed decisions are happening, and then that travels back to the edge devices for their next level of action or control. So the industry footprint is going to be something like highly connected, communicating informations, and faster way of handling the things. So it is going to be cheaper, better, and quality products. So that are going to be coming out of the industry 4.0. Okay, now look at the communications. When we said the data has to be transported, so what are the various communication options we have, and what is the range? So obviously we know power and range are directly linked. So when power is high, I get a higher range, and vice versa. But the point is, I don't have to have high power devices when I have to communicate between devices which are in close proximity. So we have devices which are at a particular data rate, and which are associated with a particular range as well. So if I have to, for example, if I have a Zigbee or a GSM, which can work at say 1 to 10 meters of a range, then I can have a lower data rate. Whereas if I have to have a Wi-Fi technology, then I have to have a higher data rate and for a higher range, maybe about 100 meters also. And GSM, you can go up to 10 kilometers with a low data rate. Correspondingly, we will have to optimize between the power. So the power, range, and data rates, they are the three vectors that are going to get optimized simultaneously. And when you look at in the application scenario, you have the entire radio frequency spectrum, and you know what all the various applications associated with the spectrum. So around the low frequency or extremely low frequency, the maritime radio is going to be used for the navigation, which we know about. This has been age old and is a conventional application that is existing. Similarly, the amateur radio is at the high frequency, and we know FM, etc., at the very high frequency ranges. Now coming to the mobile phones, which are at super high frequencies, and extremely high frequencies is going to be 5G technology. So with 5G technology, we are going to have very low latency, almost about less than 10 milliseconds of a latency. And then all the devices are going to be much more at a faster rate. They are going to be communicating. So there is going to be a kind of a higher bandwidth with update rates faster. So we will be having instantaneous video as well as audio. There will not be any buffering or that kind of problems that we are facing today. All those things will get eliminated when we move from the higher level of a technology tomorrow. And that is what Industry 4.0 is going to be using it, so that the decisions, as soon as something is sensed by the sensor, immediately the next action for the edge device is available, and there is no latency there. So safety is going to be ensured. So, and everything is going to be in autonomous mode. Next slide. Okay, so now when you compare this, just now what we have seen, range as a function of power, we have Zigbee, Bluetooth and Wi-Fi are compared here, and you can see the way how the range is changing. Zigbee is about 100 meters and Bluetooth is about 10 meters and Wi-Fi is going to be again 50 to 100 meters, and their operating frequencies are going to be different. Wi-Fi is at 5 gigahertz range, and power consumption, if you look at, Wi-Fi needs higher power, Bluetooth at a medium rate, and at the Zigbee is at a very low power. And similarly, since power consumption is going to be gradual, obviously the complexity will also be increasing correspondingly. And each one is associated with a particular topology of communication network, and that is how it is proved to be very efficient. So we have Bluetooth can have a tree topology, whereas the Zigbee can have all the possible, like a star or a tree or a mesh topology. So these topologies are basically used in order to reduce the latency and then having quick data transactions between nodes, right? So that is what. So we have. So the takeaway from here is we'll have to be conscious about which technology we will have to use for what application and what is the power level, because the optimization of power is very, very important. So that is the takeaway from here. Right. Now, having said all these advanced technologies that are going to be leveraged for Industry 4.0, are there challenges associated? Yes, there are multiple challenges. Do we have solutions? Yes, solutions are also available. So now let us look at what all the challenges we have. Of course, we know energy and range, just now what we have seen, the basic ground attenuation and the free space attenuation, that is the fundamental kind of a challenge that one has to overcome. Adjacent channel interferences are going to be more because multiple devices are going to be communicating very closely, and then fading because the multi-path travel of the RF radiation is going to create a different path loss, and hence there is going to be a constructive and a destructive interference at the receiver, which is going to have a fading effect. And channel noise, of course, multiple systems are working and the channel is not going to be a free. So it is going to be contaminated with a lot of EM radiations, and hence channel noise is going to be very high. Signal to noise ratio is a parameter that one has to be closely monitoring. Bitrate and bandwidth, of course, multiple devices working, and hence bandwidth has to be shared. And 5G is going to reduce that kind of a challenge to a larger extent, but still physically you have to be aware of there is a bandwidth restriction. It is not going to be free. Functional security, because having multiple very intelligent data is being transacted and very critical data is being transacted, which is very critical for a business. When I say if that data is compromised, the entire business objectives are going to be defeated. So now how do you make sure only right people access right data or required data? So that is what is the functional security. How are we going to build functional security? For example, if somebody accesses a particular sensor and creates or artificially induces a wrong signal into it, the entire decision process is going to be haywire, and then that may compromise the safety of the plant itself. So that is what is the security. Functional safety, we are making systems autonomous. Systems are going to be making their own decisions. Human beings are going to be just kind of a spectators. If that is so, will a machine take a right decision that is not going to compromise safety, or will it cause an accident? Will it result into a loss of life and things like that, right? So that is most important. When multiple robots are working together, what if one robot starts malfunctioning and then creates a hazard in the place around? So that kind of decisions or that kind of design practices have to be built into development itself. So that is the biggest challenge that we have with the advanced technologies. So now what are the solutions we have? Energy and range, we have energy harvesting technologies, antenna gain related things. Now innumerable antenna system designs have come up. We have slotted array antenna, beam steering technologies, and so on. So how we can make an antenna very, very directive so that it doesn't interfere, has got a very high gain so that I can have a long range, and so on. Interference, we have coding technologies, we have frequency hopping technologies, and there can be coherent receivers, right? So that it avoids kind of an interference. that is how interference has to be solved. Fading, so multi-input, multi-output transmissions and directed antennas and space-time coding are going to be very heavily utilized. And of course, remember, these are all not, this is not just an exhaustive list. This is few examples that are going to meant for illustration. Noise, of course, we have spirit spectrum communication, wherein you can avoid the noise by changing by communicating into the entire white noise spectrum. And bit error rate, you can implement with safety codes. There can be a feedback messages which will enable you to correct. And of course, the now coming the functional safety, which is much more important with Industry 4.0. And we have to be aware of how the quality of communication is going to exist. So can I utilize the quality of communication to augment safety? So that is the kind of research that we are taking up, and then trying to augment the safety in an industrial sector. And remember, the functional safety is not just applicable to the industry alone, even to the automotive industry. There were huge communication between systems, between cars, between vehicles, they are going to happen, right? So how to build safety there. And functional security, as I have told, authentication, encryption algorithm development, and access control technologies, they are all going to be playing the vital key role in solving the challenges that we are foresee for the Industry 4.0. Now, let us put all things together. What is there in it for us, right? How the world is going to be for us in future as a student and as a researcher, or as a person who is going to grab knowledge, gain more knowledge, as a faculty of any of the institutions, how the future is going to be looking for us. Now, growth is imminent and it is going to come. It is underway, as Ramesh, Dr. Ramesh said. Industry 4.0 is already on. And high-speed connectivity, data analytics, machine learning, deep learning, functional safety and security, and collaborative robots. All these things are today reality. They are no longer going to be textbook technologies. They are reality. And they are going to further and further improve in a very short span. When I say short span, in next few years, about 5 to 6 years time frame, the entire industry is going to be occupied with this kind of high advanced technologies. That is the growth. Now, when I say growth, who is going to build these technologies? Who is going to create these systems? Who is going to architect these designs? It is the technological people, engineers, who are going to do. And hence, if I skill myself today for these advanced upcoming technologies, then I am going to be the best fit in future, right? So that is very, very important for each one of us to understand. Next, coming to the communication and information systems. No need to emphasize the information systems. It is an information era. Everything is going to be data analytics driven and knowledge driven. You have to extract knowledge. Knowledge is scattered around in the form of data. We will have to extract the knowledge from the data. And once knowledge is extracted, you have to share the knowledge with other systems so that other become intelligent and take right decisions. So as a collaborative system and in a collaborative ecosystem, then the decisions taken are going to be the perfect decisions at a right time, right? And hence that is going to be a faster, cheaper and better decisions. Communication systems, mathematical modeling, information processing, computer technology, they are all going to be very, very relevant in shaping the future. So we have to be part of it. We have to have acquire necessary skills, and that skill has to be is going to match with the future and expectations of the expectations of the future. What are the opportunities? Let us look at that. In Indian context, if we see, it is very obvious the India government is really coming up with a very, very kind of a revolutionary policies to make India a better country and then to grow this country as a superpower. Make in India, digital India, smart cities, smart buildings, skill India. If you touch any of these things, they are all going to be based on advanced technologies. It's no longer going to be conventional methodology. They are all going to be based on advanced technology. And if I have to be part of Make in India, Digital India, any of these things, then I have to be a better fit into that environment. So what is going to make me as a better fit? I have to acquire the right skill. I have to have the right knowledge. Then only I can be a better person there to do and bring value add. Digital penetration and technology adoption policy. The new policy has been rolled out now by Government of India, and they are going to be, it is a digital penetration. Understand the word penetration is going to be very deep. There is no question of villages are going to be converted into moderate towns, and people are no longer going to be free from digital touch. So everyone is going to be adopting the digital world for himself. Today, even today, we can know in the villages, people have started very extensively using the smartphones. And hence, imagine if you empower them with a lot of decision making, many things can be changed in this world, right? So that is going to be the policy of the government. IoT, Internet of Things, machine learning, data center policy of the Government of India has launched all these policies. If we go to government websites, and then we can see a lot of documents which have been developed by Government of India on these policies. We can see IoT policy, machine learning policy, and even blockchain policies have been rolled out. They are all available in the free open domain. So what does that mean? The world is changing, and change is not going to be too far-fetched. It is going to be in few years from now. Almost change started, we can realize it. And imagine if we miss this bus now, we are not going to be part of that journey. So it is very important that we skill ourselves into these areas and then be part of that journey, and which is going to be taking us to a better world. Like now we have various tools here, and Python, Minitab, MATLAB we know, the NumPy, Open we know, they're all artificial intelligence, statistical tools, and then a lot of optimization toolkits and so on. All these tools, the students will be learning as part of this in this when you go through this course. Now, what are the various subjects you will touch? Everything which is under electronics, right? It will be communication systems, signals and systems, machine learning, deep learning knowledge, embedded systems, because we need to know how efficiently the new technologies are coming up and how nanotechnology is going to evolve. Wireless communication systems, analog to digital, analog and digital communication, smart materials, and then Internet of Things. So this course of communications and information system is going to touch everything. It's not, when I say touch, it is not just going to make aware, but you will deep dive into each of these subjects, because otherwise you will not be able to really solve a real world problem, right? So that is what is the subject. These are all very, very critical subjects, and you will be made as a master in these subjects if you go through this course. Yeah. So job options, when you look at, I just want to put this as this way. So let us not look at it as kind of an option for us to get into some job. The option is the world is changing, and we know that is coming up for us. And the one who is going to be knowledgeable, one who is going to be innovative and value adding, and they are the people who are going to write the future, right? And hence there are huge opportunities in front of us. It can be a mobile technology, it can be a game developer. So you need to relieve the stress. You can be a game developer, it can be a mobile application or a mobile architect, and then system developer, and so on and so forth. So India is already having a lot of the multinational companies, and that there is no doubt. And with the changing policies, they are all going to be here, and we have opportunities to work and then create value. Okay, so at this point, so if you look at, we start our journey as part of the communication and information systems in the Masters of Technology. And then our goal is basically to become a master of these technologies. And the time when we become a master, the world is ripe enough for us to really jump into the available opportunities and create value, innovate, and bring new products, and then add value and relieve the pain of a common man. So that is the fundamental objective of all these things. They're all not just to earn money. They are all going to relieve some kind of a pain, make life better for everybody. So that is the overall ambition. And I'm sure very much that this communication and information sciences, information systems is a very right combination of subjects, and which is going to create a huge value in the future, in the next few years, right? That is going to come. And there are target companies, and we have Nokia, ABB, Honeywell, HCL, Infosys, Intel, everybody, they're all already working in these areas, advanced technologies and technologies of future. And if we we have the right skill, we can join any of these people who are already adding value and create more value to this world and bring a lot of joy and happiness to the common man. So that is the overall objective of really becoming a technologically advanced person, right? That is what it is. At this point, there are alumni who have got graduated from Amrita, and are we having Snaglata today?
Hi, yeah, I'm here.
Yeah, okay, Snaglata, I think it will be better. Please, can you go ahead and express yourself? How was your experience as an alumni of Amrita?
Yeah, sure. Hi, I'm Sneha. Good afternoon, everyone. I graduated from Amrita in 2017. And in my final year itself, I actually got placed in a company called Tejas Networks as an intern. And after 10 years, 10 months of my internship, I got converted as an employee. And the credit of me getting converted as an employee just does not go to me actually. It goes to my college and the course which I have taken in my college, that is communication and signal processing, which helped me a lot in understanding what is happening in company, and my work which I was doing in company, I could do it much faster than compared to other interns in the company from other colleges actually. And one more thing is why we could do that was in our college we actually have done a lot of mini projects. Like every sem we had minimum of 3 to 4 mini projects, which actually helped us in understanding our theoretical knowledge what we had and how to implement those in practical ways. So that helped me in company also, and now I am an R&D engineer there. So I have got a really great opportunity for whatever I've studied to do in this company. So I'm really grateful to Amrita uh, and the course and my professors mainly who have given me so much encouragement of learning things. And we actually had attended a lot of tech talks, and Amrita even gives us opportunity to attend a lot of tech talks, which actually helps us getting exposure to the outside world. So I have got really benefited from this course. I hope people also get benefited from this course by taking this. I really hope this goes well. Thank you.
Thank you, Snaglata. We have David, and David has shared his message through a video. I think we can hear David. We are not receiving audio.
So that's when my wife influenced me in joining MTech in Amrita because she was doing her MTech back then. She spoke to me about the infra they had, the teachers, the syllabus, the projects that the students were involved in. So I made my decision to join Amrita, and I'm proud of it. So the next thing was I was back then before joining, I was into a small electrical firm where I was not getting paid much and it was not my domain. So my main intention was to switch the domain by joining here. So yeah, that came true, within a year. So within a year, I heard that placements had started and a a company, a cybersecurity company, which was coming in for placements there. And the job role they were offering was network security engineer, which I did not want to miss by any chance. So I started preparing for it. And you know what? It was easy for me to crack that exam. The interview. It was easy because most of the questions they asked was practically already covered in my project. The guides really helped me there because most of the things what I was doing here in project was actually all the company was already doing there. So it was easy for me. it was not only me who got placed, it was my classmates as well who got placed in different companies, good companies like Google, Microsoft, and some aerospace companies, Toshiba, all this. And some of my classmates are now into teaching, and couple of them joined PhDs. So all are well placed and all are doing good as far as I know. So I got placed here as an intern. It was a paid internship they gave me. I started paying my loans back then. So it was pretty easy for me after joining here. My life has been settled. Currently, I'm working into research and engineering in FireEye itself. It's good over here. So yeah, it was not only me, right? So all are doing good right now. I would like to say the teaching here is really good. As far as I know, they have the best teachers who have very good practical knowledge. They are always sync with the outside world, the new technologies that is coming up, and most of the projects are really interesting to work here. This has helped me to shape my life. I hope you guys also do the same. You guys also do select the right thing for your future. I am proud that I studied in Amrita even now. Yeah, thank you.
Thank you.
Thank you, David. Thanks for
I'm
those
the
good
John
words.
and alumni of Amrita College of Engineering.
Okay, thank you. So I
It's
hand over at this point to Ms. Nalini Sampath. Madam, over to you.
yeah. So we see a few questions, sir. It would be nice if you could address them. One question is, in Industry 4.0, can we see robot as a helper tool?
So let me
Yeah.
pick up this question. Let me pick up this question and try to answer this. Now, typically in an industry, how do we work in a traditional industry? We don't work in isolation. We work as a team, right? We have a team member, we have a team manager, and we all work together in order to achieve a goal. So a helper is a person who actually does a specific job. If I say, take this pen and keep it there, a helper does that. He does not think much, right? Whereas a colleague in the organization thinks along with us and helps in achieving the common goal. Robot is not going to work as a helper, but it is also going to work as a co-employee. If a robot is just doing a pick and place job, then it's definitely going to do a helper job, whereas cobots are going to be more clever. They are going to take over decisions, help human being in making smarter decisions. So I would say that cobots and robots are not going to be mere helpers. They are going to be a part of the team. They are going to be employers of the organization without getting a salary.
Okay, the next question. Can we have some examples of better jobs when compared to the routine job that supports jobs like L1, L2, L3? And related to jobs, there's another question which says, will jobs get reduced because of this automation?
Sure. These are two very interesting questions that we need to understand. And let us try to understand something which with a very simple example so that you are all able to appreciate this concept. Why does a dosa cost so much these days compared to what it was before? If we try to understand this particular question, the dosa batter which was used is the same. The stone which is used to make the dosa is the same. Fire used to make the dosa is the same. And the vegetables used is the same. Then why is the cost so high? The real reason is the person who is making it is skilled and we are paying for that person. As technology improves, if the person does not upskill himself and does not gain more knowledge, then there is a likelihood that the person will remain wherever they are and they will potentially get into an L1 type of a job. Okay. I'm not saying that L1 type of a job is a bad job and it should not be done. But the more we start learning and enhancing our career, we can graduate from a dosa maker in a hotel to a hotel manager and then to a hotel chain manager. You see, we have graduated from L1 to L2 and L3 just by acquiring more and more knowledge. So the moral of the story is keep upskilling yourself. Never think that this technology is here to stay for another 20 years. We have seen that Pokemon Go has reached 1 million customers in 1 month. We never know if This technology is going to get changed in a few days. So keep upskilling. That is the moral of the story. Will we lose jobs? Absolutely no. If you are upskilling yourself and changing yourself from a dosa manufacturer to a hotel chain manufacturer or to a hotel chain person and to an entrepreneur who is employing a few thousand peoples, your job is never going to change. Your doors are going to open up quite a lot. However, if you do not upskill yourself, you might end up staying with a level 1 job through the rest of your life, and God forbid, if the automation takes over, there is a likelihood that the number of level 1 jobs will start reducing. Smart knowledge, upskilling yourself, keeping on the innovation engine working in you is what is going to feed you for the rest of your life.
Okay, Mr. Srikanth, there's another question. As you speak about upskilling, there's another interesting question by one of the participants. It says in Industry 4.0, does every person need to learn daily or upskill every week? Say, for example, he says, does a person need to have an intermediate intermediate ability in at least 10 programming language? Is it really needed?
Sure. Let's try to understand this question in a very, very interesting way. Now, today we are speaking of Python. And today already Google has told Go language is the language, top 10 language that we need to learn. And we still learn C and C++ in our college. Is C and C++ useless? Should we stop learning those things? Absolutely no. Why? Any programming language, if you take, has got a fixed foundation. You have got a for loop, you have got a while loop, and the most important thing in any programming language is logic, right? So the first thing that any person needs to learn is how to apply an algorithm or how to apply logic. Learning a language can be done in very quick span of time. That's not an issue. However, knowledge of tools like Python, TensorFlow, NumPy are very essential in order to quickly develop your data science application or machine learning application.
Thank you, Srikanth. One last question. So, is digital twin, can it be called as a physical clone? And
Sure.
could you give examples of real-time examples of a digital twin?
Absolutely. Let me give an example of a digital twin such that everybody is able to understand. Okay, let's take an example of a car. What do we have in a car right now? We have got electronic control units which actually determine the fuel that needs to be injected in a car when the car is driving, right? So what if your fuel or your vehicle speed sensor fails? Just think of this as an example where your vehicle speed sensor has failed. Now, will your car, which is going on a highway, suddenly go clueless and say that, by the way, I do not know the vehicle speed and hence I do not know how much fuel I should inject in the car? Absolutely no. That's the most dangerous thing to happen. So what is a digital twin? A twin is a mathematical model sitting in an electronic control unit which back calculates the vehicle speed based on the different parameters that are currently present in the vehicle, right? The real physical sensor is giving you the ground truth. The digital twin is giving you a value which is close to the ground truth. If the digital twin is exactly giving you the ground truth, there is a situation in future where you can replace the sensor with the twin. This is exactly what is called as a digital twin. Digital twin is a clone of the existing system. It performs exactly the same functionality as the current system. It learns using machine learning and deep learning techniques, adapts itself so that it can supersede the real sensor and in future replace that sensor. This is exactly the meaning of a digital twin.
Hello, sir. This is Jayanti from EC department.
Yes, ma'am.
Actually, when we go with Industrial 4.0, is it we are more open so that it's more transparent? Is that we have to invest more on security and safety of information? and it is affecting the privacy of continuously monitoring, and wherever you go, all the data will be stored somewhere else. Then we have to invest more on, right, data collection,
Sure.
security, and all those things.
Sure. This is a very, very interesting point that you brought up. First thing is diverse devices. Okay. Now let us take a very simple example of Amrita as a college. You have students from different parts of India. You have students from Andhra Pradesh, Tamil Nadu, Karnataka, Punjab, Gujarat, various places. Everybody speak different languages. How do they work in harmony in a given place? Because we have a protocol conversion or a unified protocol. We should be able to accept any protocol that is being used by a given equipment like RS-485, RS-232, BACnet, Ethernet, whatever, and first of all, understand this data. That would be the most important thing. First and foremost thing is to have backward compatible protocols which can be used across devices. Second thing, the moment we have data which is stored across different places, security becomes a very, very critical thing. We must definitely invest a lot of time and energy in research on cyber security and the ways of breaching the corporate trust boundary. Okay, so there are multiple types of attacks that happen. Typical attacks that we all are aware of is man in the middle attack, denial of service attack, where you have got attacks from outside sources. But nowadays, the most important attack which we need to really deal with is called as an insider attack. An attack which is present from a person from the organization who does not feel good about the organization and thereby tries to bring the organization down. While Shiva spoke, he spoke about one very important topic about providing the required information only to the required person. Access restriction and authentication is one way we can overcome such things. Yes, you are absolutely right. Protocol diversity and investment in cybersecurity is going to be the key going forward.
I don't see any other questions in the chat window. Okay. So as we conclude this webinar, I take this opportunity to thank the chairperson and faculty from Department of Electronics and Communication Engineering for hosting this informative webinar. My sincere thanks to Dr. T.K. Ramesh, Vice Chair, Department of ECE, for briefing the audience about our university and the NTech programs offered. Thanks to Mr. Srikanth and Mr. Sivasubramanian from Intel for emphasizing the role of communication and information for Industry 4.0. Thanks to Ms. Suchitra and the admission team from Amritapuri for providing their most valued support. And a hearty thanks to our alumni, Ms. Nehalata, for their continued support. Thanks to Mr. David. Thanks to our dear students from ECCIF for providing the back-end support and hosting this webinar. Thanks a lot, dear students. So over.
I would like to thank Ms. Nalini Sampath, Department of ECE, for helping us understand all the backgrounds with respect to conducting the session, lessons learned from the previous sessions, so that this session can be made quite effective and fruitful to all. Thank you, ma'am, for your guidance and feedback.
Thank you, Mr. Srikanth. So finally, I would like to thank you all for being a wonderful audience. Thank you.
We are closing the session now. Thank you very much, everybody. Have a good day ahead.
Thank you, sir.
Thank you, sir.